Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nur Syamini binti Muhammad Syahidin. Nombor metrik DL22230.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Siti Afia binti Abdul Razak. Nombor metrik DL22238.
Part A. Analog Circuit Analysis. Task 1. Time Domain Transient Simulation in Proteus VSM. Step 1. Open new project, draw a simple rectifier circuit without a filter capacitor and pick device generic bridge rectifier into library. Step 2. Pick AC source into library. Step 3. Pick load resistor into library. 4. Select AC source from library and set it to 6 volt amplitude and 50 Hz frequency. Step 5. Connect the AC source to bridge rectifier, ground and 1 kilo ohm load resistor. Step 6. Using probe mode measure the output voltage at R load. Step 7. Using graph mode, use analog graph to get time domain analysis. Step 8. Edit transient graph stop time to 100 ms by double click the graph. Step 9. Select voltage probe and drag it into the graph. Step 10. Simulate the graph by pressing the space button at your computer. Step 11. Change it to 50 ms stop time to get more a clear waveform. Step 12. We can see the output is pulsating DC that is not suitable to drive DC circuit, so we need to eliminate the pulse by using filtering the output using a capacitor. Pick a 47 microfarad capacitor and connect it between load resistor. 13. Click graph until it turns to red color and press spacebar to simulate the output voltage. Step 14. We can analyze the maximum and minimum of the ripple by using it in the graph by simply clicking the graph and click the header when it turns red. To measure it, just click CTR and click move it to maximum point and repeat the step to get another marker and move it to the minimum point. We can see the measurement at the bottom of the graph. Task 2. CE input output characteristic using transfer function Proteus VSM. Step 1. Open schematic capture and pick transistor NPN to N2222 from component library. Step 2. By using DC generator mode, set input current for IB and input voltage for VCE. Step 3. Use probe mode to measure collector current and change the current flow direction and rename it as IC. Step 4. By using graph mode, transfer function create graph. Step 5. Input the IC probe by dragging the IC probe into the graph by add trace at graph toolbar. Step 6. Set the value for the graph according to figure below by double click at the graph. Step 7. Run the transfer function graph simulation by clicking on the graph until it changes to red and press spacebar or right click and select simulate graph. Step 8. Change the value of Y scale to 0 to 30M. Step 9. Maximize the graph to analyze the IB, IC and VCE value.
Task 3. Transistor bias analyzing using Proteus VSM. Task 3. Transistor bias analyzing using Proteus VSM. First, open schematic capture or create new ICs project and construct the schematic as shown in figure. Next, by using DC generator mode, set VCC supply for 12 volt and click OK. After that, use sine generator mode to give an input signal for the amplifier. Set amplitude to 1 volt and frequency to 50 Hz and click OK. Step 4. By using instrument mode, select an oscilloscope to measure the input and output signal by connecting to in and out terminal. After that, run the simulation and adjust the oscilloscope to get the proper waveform output. After that, by increasing and decreasing the RV1 value, You can see what will happen when bias is too high and when bias is too low. Step 7. Use graph mode and select frequency graph to investigate the frequency response. For this circuit, use voltage probe mode to check the output voltage for this amplifier. Drag the probe mode into the graph. After that, edit frequency graph by double-click on the graph. Set the reference input signal. You can start frequency at 0.01, stop frequency at 100 MHz. Interval by decades, set option to always simulate and click OK. From the frequency response, you can check the bandwidth, FCL, FCH, AV mid, and row of rates near FCL and FCH. Step 11. Edit frequency graph and set Y scale to dB. Simulate the graph and maximize the graph to analyze the frequency response. From the graph, AV mid equal to 40.5 dB minus 3 dB equal to 11.5 dB. So the cut-off frequency will be 11.5 dB. So FCL equal to 430 MHz and FCH will be 4.06 MHz.
For discussion, the question, choose one electronic component and find the characteristics same as step in task 1 and 2. Discuss the finding. For task 1, we change bridge to triac. The step is same as task 1 step. This is the result for task 1 discussion. For task 2, we change transistor to triac. The step is same as task 2, and this is the result for discussion task 2.
For the conclusion, we were able to draw electronic circuit design software tools. Besides, we also able to analyze the electronic circuit using software tools. Last but not least, we were able to build good working environment, interaction with others, and effective collaboration to achieve a common target.